All right, so I had a couple of questions from a student about review number 11, specifically about number 4, and I believe, let's see, number 14. Let me check my messages here. Yes, so number 6 and 14, excuse me. So when it comes to a problem like number 6, okay, so forget about number 4. That's not what she asked a question on. We may need to have more room here, but essentially what's going on here is I remember that I could actually rewrite this as e to the r times e to the s. And the reason why is, remember, if we go backwards, right, by the rules that you learn about exponentials back in Algebra 2, when you multiply two exponential functions and they have the same base and you add the powers, right? So we're essentially going backwards. So now that we know that, what we're going to do from here is essentially we're going to use the separation of variables, right? So let's see, we're going to multiply both sides times ds. So let's see, this side I know will be the integral of e to the s ds. And on the left side, you would have dr over e to the r. So basically you would have this. So don't write this yet, but you would have this, okay? Now, I could and I will actually rewrite this. So hopefully you don't write that because that's not how I'm going to write it necessarily. I'm going to write this as e to the r. If it's on the bottom, right, I can rewrite it as e to the negative r. Let me zoom in so I don't write too small here. dr. Okay. Now when we integrate that, remember the integral of e to the s is just e to the s plus c. Now on the left side, the antiderivative of e to the negative r would be negative e to the negative r. And the reason why is because, remember, we basically do u substitution. You can do that on your head too if you wanted to. And du is equal to negative dr. Right? And I don't need the negative, so I would basically put the negative out here, put the positive. And also it'd be useful for you to know that the antiderivative of e to the u is just e to the u times the derivative of u, so du dx, I suppose. Let me see, am I telling you the truth on that? No, I'm not actually. The antiderivative of that is just that. Okay. So anyway, so after that, okay, we're gonna, since I want to find the particular solution to the differential equation, we're actually gonna use the r. Let's say r of 1 is equal to 0. So when s is 1, then r is 0. Okay. So it's gonna be like 0 power here, and this is e to the first plus c. Now e to the 0 is 1. Let me see how they decided to write it because I'm seeing something kind of weird up here. Okay. So c is going to be equal to, this is negative 1 right here, right? So we're going to write this as negative 1. I'm going to subtract this from both sides. And I'm looking at the key here real fast. I just don't know how far they want me to go. Okay. So then the answer you would have is e to the negative r. So I'm going back to this and I'm just plugging out what c is. All right. So e to the negative r is equal to e to the s. And c is going to be all of this. Okay, so finally, obviously, remember what I've told you this before. If you were doing an AP exam, you would just leave it like that. I'm done. I'm not simplifying anymore, right? But because the answer that I gave you is, let's say there was multiple choice, you didn't see that answer, right? Then what they do is they put basically the constants on the right side and the functions on the left side. So they did something just weird. basically what they're doing here, and I can't remember what the answer they gave you. Basically, they move this that I just underlined to the left side, and they added this to the right side. Okay, so you can see that my answer, if I do that, I would have e to the s plus e to the r, e to the negative r, excuse me. Is equal to e plus 1, or 1 plus e, whatever. But that's how they got that. Okay. Most people struggle with this step. They don't really know what to do with that, but that's the key for a lot of people. All right, so let's go on to number 14, I believe. Okay, so it says write an equation of a curve that intersects at right angles. Every curve of the family y is equal to the natural log of x plus c. All right, so let me look. Okay, so what you're going to do with that one, all right, is that at the right angles, when it talks about, how do you know the two lines? Let's just talk about two lines. How do you know they're perpendicular, all right, which is what a right angle is, right? You know that their slopes are opposite reciprocals, right? Now, if I wanted to know the angle, if you will, or the slope of every tangent line on this family, what would I do? Wouldn't I take the derivative of that, right? So basically what I would do here is I would start off by taking the derivative of that, which is the derivative of the natural log is 1 over x times the derivative of x, which is just 1, so I'm just going to leave it like that. All right, so again, this represents the slope of the tangent, or this formula will give you the slope of every single point on there, assuming you plug in a different x, all right? So if I want an equation that intersects our right angles, what I'm going to do here is I'm going to take the slope and take the opposite reciprocal. So the perpendicular slope, if you will, would be the negative reciprocal of what I just wrote, so it'd be negative x, okay? So this is a part that you need to go here with me, right, and understand. So what I just found here is the derivative of the curve that I'm trying to look for. Okay, so again, what I found here, this is the derivative, and let's call this function g. I found the derivative of the function or the equation of the curve that I'm looking for. Okay, so if this represents the derivative of the curve that I'm looking for, what I have to do now is I have to take the antiderivative, right? So this is basically the second part of this. I have to take the antiderivative of the derivative of function g, which is what I'm looking for. All right, so now I'm going to take that. And let's call this, well, that one's g of x. So this is going to be equal to negative x squared over 2 plus c. Okay. Now, what happens after that is that's basically it. That's the answer. Now, I know on your key they probably just wrote negative x squared over 2, but I can't understand why they would get rid of the c, because you would have a different c for all of this. Okay, so that's pretty much it for that. All right, guys. Well, if you have any more questions, try to get a hold of me, and I would be glad to answer. Right? We can also do Zoom if you like, but just let me know.